Linear equations can be combined into systems of equations, which enable us to find values for all of the variables that satisfy all of the equations. Now, this is useful if you need to find a specific pair of x and y values.
Suppose, for example, you feel like a healthy snack and you decide to buy some fruit. The fruit store has apples, which cost 5 cents, and oranges, which cost 15 cents. Now let's say you spend 75 cents and you buy 9 items of fruit. So how many apples and how many oranges did you buy? Well, let's start with what we know. We know that you have an unknown number of apples, let's call that x, and an unknown number of oranges, which we'll call y. And in total, we have 9 items. We also know that our unknown number of 5-cent apples and our unknown number of 15-cent oranges cost us a total of 75 cents. Now, our 9 fruits could be 9 apples and no oranges, or no apples and 9 oranges, or any combination in between where x plus y is equal to 9. So here's a line for that equation. Similarly, 75 cents could buy you 15 apples and no oranges, no apples and 5 oranges, or some other combination where 5x and 15y is equal to 75. Now the lines from these equations only share one common point, where x is 6 and y is 3, which indicates that you bought 6 apples and 3 oranges. We can also figure this out using what's called the elimination method. First, we need to manipulate one of the equations so that the term we want to eliminate, in this case the x term, cancels out the same term in the other equation. So to do this, we're just going to multiply everything in the first equation by -5. Now we can add these two equations together. -5x plus 5x is 0, so that eliminates the x term. And -5y plus 15y is 10y, and -45 plus 75 is 30. So if 10y equals 30, then y must be equal to 3. And now, from our original equation, we know that x plus y is 9, so if y is 3, then x must be 6, which confirms you bought 6 apples and 3 oranges.